you want to go? Come on then. Okay, question 7 is our wordy differential equations question, which people usually hate. But if you know the best, most efficient way to do this question, which just comes from practice, it's actually, I think, quite straightforward. You might well disagree with me, but let's see how we get on. So we've got the differential equation set up already. It's told us some important information that we're going to need later in the question, but the first thing it asks us to do is solve the differential equation and write a in terms of t and k. So that's important. We need to make sure by the time we finish the question we've got a equals something. So to start, I'm going to bring this dt up here so that we've separated the variables. We don't need to do anything with this expression here at the moment. That's a dA, and that's just going to equal kdt. Now that we've separated the variables, we can integrate both sides, and that will get a out of our equation for us. So when we integrate the left, we're going to get natural log a. Be careful of this one. This is going to be minus natural log of 250 take a, because we're pretending it's an a and integrating, which would be natural log of 250 minus a, but we also need to divide by the coefficient of a, which in this case is a minus 1. Dividing by minus 1 is the same as timesing by minus 1, so that's why this is a minus. That is then going to equal kt, and I'm going to put my plus c on this side. I could put it on either side. I'm going to have it over this side. It doesn't matter either way. It will end up being the same value for all of us, no matter where we put it. Next thing I'm going to do is just simplify this into one log. I'm going to use the log rule, where a subtraction of two logs is the same as the log on the left divided by the log on the right, just to make this a little bit more simplified. And now I think it's quite a good time to calculate c. We can use the fact that at the beginning of the question, one of those things I underlined was that when t is 0, a is 10. So I'm going to use that now. When t is 0, a is 10. So if we substitute that in, we're going to get natural log of 10 over 240 needs to equal nothing, k times 0 is 0, plus c. So c is equal to the natural log of 1 over 24. I'm actually going to rewrite that as 24 to the minus 1 and bring the power to the front. So I'm going to have my c value as minus natural log 24. You'll see why in a minute. Because what I'm now going to do is put it into here. So natural log of a over 250 take a equals kt minus natural log 24. But let's put this 24 over the natural log 24 to the other side. Natural log a over 250 minus a, add natural log 24 equals kt. Now why have I done that? I've done that so I can now bring these two terms together. When we have two logs added together, we times them. So I can now write this as a single log. Log 24a over 250 take a is equal to kt. Now the reason I've done all that is because we know we need to make the equation a equals something. And having it as a single log like this will allow us to now reverse that log and bring in some e's. If the natural log of this is equal to kt, so if, for example, we've got natural log of x is equal to y, we know that x is equal to e to the power of y. So this is like my x, this is like my y. So I can now write that 24a over 250 minus a is equal to e to the kt. So I've got my a's out in the open, out of that log stuff here, and that's really important because now we can make a the subject. To make a the subject, I'm going to bring this 250 minus a up here, I'm going to multiply those brackets out, so 250 e to the kt, take a e to the kt, so that I can then put the a's together on the same line. I can add a e to the kt, I can factorise the a's out, and I can divide by the bracket. So this is quite a fiddly question. It's quite awkward at the end because of what they've asked us to do. But once we get there, it's not too bad. It's quite straightforward if you've had enough practice to know the steps that we're going to need to do. And I think earlier on where we brought this into one log, I think that's a really important step to help you get to the end.